Got a video on scalar, or what's also known as dot product of two vectors. So when we talk about being a dot product, we're going to represent it as vector u dot vector v. Now the dot will be in the center, so that will be noticeable. If you were to look at your reference sheet, it says that the dot product of vector u and v is the magnitude of u times the magnitude of v times cos theta. It's also equal to the x components of multiplied together added to the y components added together, multiplied together. That's noting that both vectors are non-zero, so that's how it actually applies. For the components of a vector, if we've got component I times I or j times j, then they're going to equal to 1. And if it's that's the vectors I times I and j times j. If we've got vector I times dot vector j or vector j dot vector I, they will equal to 0. And we'll look at those as we come through some examples. Points that are worth noting. If one of the vectors is a 0 vector, then the dot product is going to be always equal to 0. Really important is if the vectors are perpendicular, then the dot product equals 0. Or if the dot product is 0, that means that the vectors are perpendicular. Is probably a better way of looking at that. The angle between any vector and its scalar multiple is 0 because they're going in the same direction and one's just on top of the other. So there's no angle between them. But the angle between the vector and its negative scalar is 180 degrees because they're going in opposite directions. The angle between negative u and negative v is theta, and the angle between the positive vector and the negative is 180 minus. So the similar concept to number 3 and 4 that we saw up there. So these are some examples that we're going to look at. So if you'd like to pause it and take these down, we will continue to look at these one by one. So the first one is just sort of an observation that we've used before anyway, but vector u, the dot product of vector u and vector u, because they're going in the same direction, but if you want to look at it, so vector u dot vector u is the magnitude of u times the magnitude of u cos of 0, and cos of 0 is 1, so you get the magnitude of u squared. Something that we've looked at in previous video anyway, but just emphasizing it now, we're using dot products. When you do the dot product of u and v, where u is 2, 4 and v is 3 minus 2, so using one of the formulas on the formula sheet, it is x1 times x2 plus y1 times y2. So you just times the x components, adding the y components times together. So 2 times 3 plus 4 times minus 2 gets us minus 2. If we've got an angle between the two vectors, then we use the other rule, which is vector u times vector v is equal to magnitude of u times the magnitude of v cos of the angle. So in this case, it's 10 times 8 times cos of 60, and cos of 60 is a half, so that gets us 40. If we're trying to find the angle, then we use the same formula. So here we know the dot product is minus 25, and that's equal to the magnitude of u times the magnitude of v, so that's 10 times 5 times cos theta. Divide by the 50, so you get minus a half equals cos theta, and theta equals to 120 degrees using our all stations to central. For the expansion, it works like expanding brackets, like quadratics. So you'll do 3i times 4i, that gets you 4 vector I dot I minus 6ij plus 8ji minus 4jj. Now remember, the rule is that if it's I times I or I dot I, that's equal to 1, and j dot j is equal to 1. But I times j is equal to 0. So working that out, you end up with 8. Checking if a vectors are perpendicular. So the rule for perpendicular is if the dot product equals to 0. So for this one, multiplying the x's, multiplying the y's, so 3 times minus 2 plus 4 times 1.5. If you do that, you actually end up with 0. Those vectors would be perpendicular. These ones, multiply them together, and you get 2 times 1 minus 1 times minus 2, and you get 4, so the vectors are not perpendicular. Thank you.